Hello, boys and girls. Today is May 11th. This is Chapter 10, Lesson 5, Triangles, page 332 in your textbook. I'm going to be... so just follow along with me here, okay, guys? If you're looking at page 332, you see that we're going to be learning about 6 different kinds of triangles, but really there's 2 categories, okay? The 2 categories are based on, the first category is based on the sides. So let's write down sides here. And then skip like 1, 2, 3, like 7 lines. And then here write angles, because the other way we classify triangles is based on their angles. So considering the sides. So when you look at a triangle, you can tell if it is a scalene. And I'm having you write this down because it will help you on your homework. A scalene triangle, an isosceles triangle, or an equilateral triangle. And they all have pretty simple definitions. Scalene means each side of the triangle is a different length. Isosceles is that 2 sides are the same length, but one is not. Equilateral is just like it sounds, it's equal. So all sides are an equal length. This, I imagine, is a review. I imagine this isn't the first time you've learned about this. Okay, triangles being classified by their angles, that might be new. Let's go ahead and take a look at that. So the first type of classification based on angles is an acute triangle. This word should be familiar because you just learned about acute angles. An acute angle is when the angle is less than 90 degrees. Okay, so if you had your protractor out and the angle went like that, straight up, it's 90 degrees. If the angle went like this, it's an acute angle, somewhere less than 90. So an acute triangle is when there are 3 acute angles that make up the triangle. Then there is a right triangle. Pay attention to these numbers, okay? An acute triangle has to have, all 3 of the angles have to be acute angles. A right triangle will have 1 right angle. And it can only be 1 right angle. If you had more than 1 right angle, it just can't be a triangle because the sides couldn't connect to each other. Okay, and then so when you're looking for a triangle to see if it's right or not, just see, is there 1 right angle? And then finally is an obtuse triangle. So an obtuse triangle is 1 obtuse angle makes the entire triangle an obtuse triangle. Okay, so let's get to work. We're not going to do all the odds. We're just going to do a handful of them, okay? So first, we're going to look at number 1. Please redraw this with me as best as you can. So number 1 goes like this. It's got a straight up and down line here, and then it goes off to the side, and you're going to see they have a little dash there and a little dash here. In geometry, when you see a dash and a dash, that is the textbook trying to tell you that these 2 sides that have the same little dash in them, even though I made a sloppy dash. There you go, that looks better. These are equal sides. So if it has the same symbol in both of the sides, they're equal. So it's saying both of these sides are equal length. Okay, look back up here to sides. Which of these 3 types of triangles has 2 equal sides? Okay, it's an isosceles triangle. So you just write isosceles triangle. Then you look at 2. 2 is kind of crazy looking. So 2 goes kind of off here, and then you look, this diagonal side goes past the base here. So it goes all the way out here, and then it kind of goes back down like that. So you need to classify it as scalene, isosceles, or equilateral. It would be helpful to take out a ruler and to measure each of your sides if you can't tell right away. So this side is about 4 centimeters. This side is about 6.5 centimeters. And then this side is about 2.5 centimeters. So all three sides are a different length. And that is which one? Okay, scalene. Three, it looks like this. And once again, you have this equal marking here. 2 dashes here, 2 dashes here. That means those two sides are the same. This side does not have that marking, which means it's not the same. So this has two identical sides. So this is another isosceles triangle. Four is like this. Dash, dash, dash. The same dash in all three sides. So when it's all three sides, that's an equal lateral triangle. Okay, look at number 5 in your textbook. Let's look at it. We won't have to write it down. What do you think 5 is? Say it out loud. 5 is equilateral. Look at 6. What do you think that is? Go ahead and measure it. Pause the video, measure each side, and then unpause it. Okay, that one's scalene. 7. 3 dashes in each side. That one's equilateral. 8. Isosceles. Okay, 9 looks like this. Okay, you can take out your protractor to decide if it's an acute triangle. All three angles, so here's the angles in our triangle here. Got an angle here, here, and here. For it to be acute, all three angles would have to be acute angles. For it to be right, you would need just one right angle. For it to be obtuse, you would need just one obtuse angle. Okay, that one I know is automatically, that's acute, definitely. That's way smaller than a box, you know? And if you don't remember what a right angle looks like, it's in every single one of these graph paper boxes. That is also not a 90-degree angle, or else it would go straight out with the graph paper box. But this one, I set up my protractor with my base. This ray should touch 0. This should go right to 0. And then this ray you're going to see goes straight up to 90. So this is a right triangle because it has one right angle. I'm going to erase that little circle and put my right angle box now that I know it's a right angle. Let's look next. Okay, so number 10 looks like this. Okay, if you don't remember what the how to classify the angles of triangles, look back and read that. So this is definitely acute. This is definitely acute as well. This one, let's see, right here. So line up this ray with your 0 degrees. Line up the vertex with your base of your protractor. And with my ruler, I'm going to extend this ray out to my protractor. And look, that ray is about 130 degrees. See that? So it has one obtuse angle, which makes it an obtuse triangle. And you can't have more than one obtuse angle. Look at this, guys. So here's an obtuse angle. If I made another obtuse angle with this line here, so that would be a 90-degree angle. If I made another obtuse angle, that's not a triangle. So you can only have one obtuse angle in order for it to be a triangle, or else the three sides wouldn't connect to each other. Okay, so that's 10 is obtuse. 11. It's like this. So it's got a straight line. Kind of goes in like that, and then it goes down like that. So you measure each angle. That one's certainly acute, because you can see it's way sharper than the box of the graph paper. If you measure this angle here, that one is about 65 degrees, 70 degrees. And then if you flip your protractor and measure this angle at the top here, this ray shoots out to about 60 degrees. So this has got 3 acute angles, all less than 90 degrees. That makes the triangle an acute triangle. Okay, 16. Go to 16. 16 is one that's trying to trick you up. So 16 looks just like this. Okay. First of all, what do you think that is? Say it out loud. I say it out loud because that makes you think about it. You might not think about it if you just are watching and not really participating. So say out loud, what kind of triangle do you think that is? Based on the angle, not the sides. Okay, let's measure. So this angle here, if we were to go line up this vertex with the base, this ray shoots out to 0. This angle here is about 40 degrees. This angle here, if we were to line up this ray with our base so that it points out to 0, this angle would shoot out to about 45 degrees. But look at this angle here. You line up this ray with our base to shoot to 0. Well, this ray shoots right up to 90. So this is a 90-degree angle. So not all right triangles look like that, where the 90-degree angle is on the bottom. Sometimes the 90-degree angle is at the top. Sometimes right triangles look like this. And you might get really confused and think, oh, that's not a right triangle. Well, you got to be very careful with these angles that are at the top because it's harder to tell that it's a 90-degree angle when it's not sitting on the ground like this. If the right angle is at the top, you might not be able to tell. See, well, did I do a good 90-degree angle? No, I tried to. That's about 100 degrees. But anyways, sometimes when the 90-degree angle is in the top, you don't recognize it right away. The last thing for you, if you look at the top of page 333, the sum of the measures of the angles of a triangle is always 180 degrees. This is just a math fact that will be with you for the rest of your life and the rest of the universe. That's just how triangles work. So if you measure the angles of your triangles, you're always going to get 180 degrees. That's just how it works. To prove it, I'm going to draw a triangle. Any triangle. I'm just going to draw a random triangle. Oh, as my pencil lets me. I was advised by a student to stop using mechanical pencils because I break the lead 5 times each video. But I've decided to keep using mechanical pencils because it makes me grow in character and patience. And you too, when you watch me break my leads. Okay, so let's measure all 3 of these angles. I promised it's going to equal 180 when you add them up. Okay, and I just drew it randomly. I didn't design a special kind of triangle at all. So line up this with my vertex. This points to 0. Well, this line points to 130-ish. Because I'm kind of estimating, it won't be exact. So that's about 130 degrees. Measure this angle here. So there's my vertex. I line up that ray with 0, and then this points to right about 20 degrees. And then I'll measure this last one right here. Remember, this has to point up to 0. Okay, so this points to 0. I have to make sure I don't point my one ray to 180. And then this, okay, very sharp angle, very small angle. This ray points to about 25 degrees. Okay, and then if you add up your 3 angles here, 0 plus 0 plus 5 is 5, 3 plus 2 plus 2, 7, and then 1 plus those are 1. So it's 175. It's 175 because I wasn't exact, but that's very close to 180. If I had a little bit more of a precise protractor than this paper one, it would have equaled 180. Okay, so the questions you're being asked are these triangles possible? Well, what they're saying is, do the 3 angles add up to 180? That's all you got to do. So for 17 onwards, you're just trying, 17 through 20, add the angles, see if it equals 180. So is this triangle possible? It says 70 degrees is one angle, and you need to add that to the other angle, which is 90 degrees, and then you need to add that to your other angle, which is 30 degrees. Basically, if these add up to 180, then yes, it's possible. If they don't add up to 180, then no, it's not possible. That's time number 3, the pencil broke. Okay, and then 7 plus 9 is 16. 16 plus 3 is 19. So that's 190 degrees. Is it possible for a triangle to add up to 190 degrees? No. So the answer is just no. 18 is, and that doesn't mean the drawing you're looking at is a real triangle. That just means that the drawing on number 17, those aren't actually the measurements of those angles. That's all that's saying. So, okay. So here we have number 18 would be 100 degrees is one angle, plus 15 degrees, plus 20 degrees. Add them up. 0 plus 5 plus 0 is 5. 0 plus 1 plus 2 is 3. And then 1 plus nothing is did I do something wrong? No, I didn't do anything wrong. Okay, so, yep, so that's 135 degrees. So, yeah, the answer is no. Okay. 19, I'm just going to do it real quick, okay? So 19, you would have had 60 plus 60 plus 60. And then 6 plus 6 is 12, plus 6 is 18. So this one is yes. Okay? Last, you can actually find for unknown angles using this rule.